Hello there. In this video I want to talk about, this is going to be a quick video on geodetic systems. Geodetic systems. Alright, the geodetic system is a mathematical representation of the Earth. Alright, so the Earth is kind of an undulating looking thing like this. So this is Earth. And Earth is, as you can see, it's really hard to define this shape mathematically, right? I mean, there's no real geometric shape that defines that. So what geodesists do is they simplify it. And they said that, okay, what geometric shape can we put on top of this that will fit it the best? Right? What geometric shape will fit that the best? And they thought that an ellipsoid would fit it, right? And it does. It draw an ellipsoid on here, best I can. Right? So this yellow thing here is my best representation of an ellipsoid. Right? And this is oblate. The ellipsoid is oblate. Right? Meaning that the horizontal axis, which is defined as 2a, right, so this whole thing is 2a, is larger than the vertical axis, which is 2b. 2b or not 2b? Okay, so with an oblate ellipsoid, A, or 2a, is greater than 2b. Or if you divide both sides by 2, A is greater than B. Right, so that is the these are the two axes of an ellipsoid. So then once geodesists defined this ellipsoid, right? I mean, this is just a general case, right? There's a lot of specific ellipsoids. There are many ellipsoids that define the Earth, and one of these that I'm gonna give an example of is the World Geodetic System. It's the WGS 84. So the World Geodetic System of 1984. Alright, so this system has certain mathematical parameters that are unique, right? There's an A is equal to something, B is equal to something specific, right? It's not like they're just choosing a number. They chose a number for each of these that fits the Earth really nicely. So once they defined this, they picked a coordinate system that would fit the Earth, which is latitude and longitude. So they have latitude and longitude. Alright, latitude is usually represented as, as phi, and longitude is represented as lambda. Oh, that was a bad lambda. Let me try that again. Lambda is like that, kind of. Okay, so latitude is 0 at the equator, right? 0 degrees of latitude at the equator. Right, and longitude, they define the prime meridian, right, where it's 0 in Greenwich in England. So 0 degrees is Greenwich. Greenwich, England. Right, that's the prime meridian. Right, the prime meridian is in Greenwich in England, and that's 0 degrees. Okay, so north, for latitude, so this is 0 degrees, right at the equator. 0 degrees. And as you go north is a positive, right? Positive. And then as you go south is negative. So, and it goes up to 90 degrees, right? If you go from the equator angularly to the North Pole, right, this angle here, right, it goes up to 90 degrees. So this is going to be the North Pole. And this would be the South Pole. So same thing, if you're defining it south of the equator, it would be 90, goes up to 90 degrees, it would be a negative 90 degrees. And for longitude, for looking down at the Earth, I'm just gonna, that's bad, but whatever. If the North Pole is right in the center, right, we're looking down at the Earth now, so the North Pole is a little dot. Right, and this is the prime meridian. A positive longitude is easterly of the prime meridian, right? So it's this way. That's a positive longitude, positive lambda. And negative is if you defined it west, right? If you went this way, that would be a negative lambda. Right, a lot of people in the United States define, many people define longitude in the negative direction. Right? Many people define it in the negative direction. So where I live is around negative 71 degrees, right? 71 degrees lambda. And if I define that positively, that would be what? It would be 360 minus 71, which is 2, 16, 15, 10, it's 9, 3, 8, it would be 289 degrees, right? Positive would be 289 degrees. So these two would be the same position longitudinally on the Earth, right? These two would be equal.